Okay, so problem number 5 is a lot harder, and so we're going to start back up at the top of the directions, and it says simplify if possible, factor. So I'm going to go to the bottom of my paper, and I'm going to factor at the bottom so that I have space. If I go down here and I do number 5, on top I can plot an x, and then I'm left with 5x minus 3. And on bottom I can pull out an x, and then I'm left with x squared minus 8x plus 16. And then you can factor that again, so you have x 5x minus 3 over x times x minus 4, x minus 4. So now I have it factored. Life is great. Anything that cancels out causes a hole. So these x's would cancel out. So I take that factor that I canceled out and I set it equal to 0. So x equals 0, which means I have a hole up here at 0 comma something. To find that something, you're going to plug in the 0 back to everything right here that was left over. So we've canceled those out. So to find the y part of the hole, 5 times 0 is 0, minus 3 is negative 3 on top. On bottom, you're going to have a negative 4 times a negative 4, which gets me 16. So the y part of my hole is negative 3 over 16. Okay, and so now I've done number 1, life is great. And then number 2 says find and plot the x and y intercepts. So I'm going to go back down here to find the x-intercept. We'll do that second. We'll do the y-intercept first. To do the y-intercept, you let all the x's be 0. Well, if you look at the original problem up here, if I let x be 0, 0, 0, 0, 0, 0, everything becomes 0. So I know that my y-intercept is 0, 0. And you should know that 0, 0 is also an x-intercept, but we need to make sure check that we don't have another one. So to do the x-intercept, you let pretty much the numerator equals 0. Well, the 0, 0 comes from this front factor. This comes from the x. But you also have this 5x minus 3. So 5x minus 3 equals 0. So you add the 3 and divide by 5, so x equals 3/5. And this right here isn't really going to happen, because x equals 0 is my hole. So x equals 0, 0 isn't going to count as that also. It'll be there, but it's okay. And then I have another x-intercept of 3/5 comma 0. So if I go over here to my graph, at x equals 0, I have a hole at right there. And then I'm there, and right there. So a bunch of little dots all together right now. Okay, if I want to find my, go to the paper, and the next thing you should find is your vertical asymptote. So to find your vertical asymptote, you're pretty much setting the denominator equal to 0, so I'm going to have x equals 4. And then to find your horizontal asymptote, you do bobo and ECC. And this is big on bottom. This is a bobo. So y equals 0. And I can do my domain now. And before we do that, let's just check and see how we're doing. So we're doing good. I have this asymptote, I have this asymptote, but if you notice, they don't have any of these dots in here, and that's because this asymptote was here, so these dots can't happen right there, so we don't need to worry about those dots. So I have this asymptote, and now I can either plug these values in, or I can use my table again. And I'm going to opt to use my table and just throw it in the calculator. So on top you have 5x squared minus 3x. And on bottom you have x raised to the third minus 8x squared plus 16x. And then I'm going to do my control T. And see, at 2 I'm at 1.75. At 2 I'm at 1.75. And at 6 I'm at 6.75. So at 6, I'm at 6.75, and you can keep graphing other points, like at 8 you're at 2 and a little bit. If I want to go the other way, like at -1 you're, down here. So now you can see that this side does that, and this side does this. And so if I want to write my domain, I can't be 0 and I can't be 4. So negative infinity to 0, 0 to 4, and 4 to infinity. If we go check, we have that right, 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 and we have this graph. But if you look, this graph more accurate really does this. And it crosses that horizontal asymptote, which we're going to talk more about in another section. So it's okay right now, don't worry about it. Hopefully these 2 videos helped you remember how to graph rational functions.